So we're live here at Star GB's open house on Thursday. It's been open 2 days already, Tuesday and Wednesday. Busy day yesterday. I know that this was certainly attracting a lot of interest, and this is what myself and Gio are going to look at now. Now, one of the highlights here at the show has been this robot here, which is actually working in conjunction with the sliding head lathe. Gio, you spoke to Andy Armstrong from Fanuc the other day about this, didn't you? What did you pick up?
Well, I think that this is a new kind of automation solution for sliding head products. Now, it's not just got the Fanuc robot, but it's got the Renishaw Equator. And effectively what it is doing is that sliding head machinery is renowned for running overnight 24 hours a day, but sometimes tools can wear during that time. So effectively, not only is it automating the process, it's actually checking the part, sending data back to the machine tool, and changing and tweaking the offsets to compensate for any tool wear, so it keeps all the components to mid-limit.
It's a three-way partnership, this, between Star, who have obviously got the machine, which is the sliding head lathe, which is machining these parts, Fanuc on the robot side, and then of course Renishaw with the Equator system. You can see there the parts being measured on the Equator system. Now, what I found interesting about this was the fact that it's more of a comparator. In this instance, it's a comparator. It can be different to that, but it's a comparator. So what happens is they take a component to start with, and they call that the perfect component. That is mid-limit. And then what the Equator is doing is measuring the part and comparing it to that previous part. And if it falls outside of certain tolerances, then of course it's going to then either put it in the pass bin or the fail bin. For me, checking parts on a sliding head lathe has always been quite difficult because of the nature of the platen. So having probing and stuff in the machine isn't quite the same as a fixed head machine. And I think really this is where this particular solution scores.
But not only that, Paul, when you're doing sliding head work, you're doing very, very high volume. And I've been into sliding head shops where they might only check 1 in 50 components. You know, the next day when it's full, 1 in 50. You know, it might be too late then. They might come into half of the night's work being scrap. So not only is it comparing it to a good part and making the necessary arrangements, it's giving you peace of mind to be able to run 24/7. And you haven't got to come in and inspect the parts again. They've already been inspected, Paul. It's being automated. They're not dropping into a bin and potentially getting damaged either. The benefits to a solution like this are huge. It's incorporating Industry 4.0 or digitalisation, however you want to, or whatever you want to call it. This is an absolutely fantastic solution, and we've seen it here at Star.
The two areas for me where it really comes into its own is the fact that if you were trying to do what this is doing on a part like this, I look at this, you'd have two scenarios that you're getting rid of. It's firstly the labour of the check-in, so with your vernier calipers, your micrometer, or however you're doing it. But then secondly, having to then go to the machine and manually put in the changes to the offsets. Now, both of those you could actually introduce errors. And that's really what you're eliminating here using this system. Go on.
Yeah, I mean, you've just hit the nail on the head. You're creating a complete, stable process. You're making it foolproof.
That's it from us here at Star GB. Now, there'll be more coming throughout the day. In fact, in a few minutes, we're going to look at the new SX38 machine here. So yeah, hope you like this solution as much as we do. Did it work?